My name is Pandian Velaidam. I'll take briefly 20-30 minutes to talk about how we built a analytics platform for our hospitals. We have most of the hospitals in rural and they are using this. This is a game changer for us. So I'll be talking about what are the business need, how did we build it, and also what we learned. The purpose of this session is for us to provide you what are the things we learned so that you can use it. Definitely we will go through the architecture as well and explain why we selected that architecture as well. To get started, I'll talk about MEDHOST so that you have a background of what we do, and then talk about electronic health record. I'm not sure how many of you are from here healthcare background. If you are not, you will get to know about what EHR really means, and then what are the needs of analytics, and then go through the solution architecture, lesson learned, and benefits like I said before. So MEDHOST, almost we are reaching 40 years mark in another 2 years, and we have 600 plus employees working for MEDHOST. We have, our software is used nationwide. In a hospital setup, in emergency room setup, in operations room, in acute care facilities, and also long-term acute care facilities it's used. We'll go through that. So multi-facility corporate customers use our software, and also we have that, like I said, general care acute facilities, and then critical access hospitals, inpatient behavioral, and then long-term post-acute care hospitals, all these places. So we have software from registration to finance, every part of the hospital workflow, we have a software for that. We have been using AWS, or we have a cloud presence almost 9 years. If you are a healthcare professional, you might hear about meaningful use. When meaningful use started, government said that the health data is not owned by hospital, it's owned by a patient. So patients should have access to their healthcare data. So we had to provide a patient portal for our hospitals. That time we chose AWS as our partner, and then start building our solution on top of AWS as a multi-tenant solution. So we have become officially became an AWS partner last 3 years, and then we utilize infrastructure as a service and also platform as a service for AWS. All our solutions are provided as a software as a service to our customer. We have been using microservices architecture within our cloud space, and we are moving towards serverless technologies. You will see that in the presentation when we go through the architecture, you will see that how we are moving towards that serverless architecture. This is just a colorful diagram here. This is to show that what are the services we currently use within AWS architecture. For past 9 years we have been doing, so we have been keep adding solutions to build on top of that. This is just to give you an overview, because when I say that we have been working on AWS, it's not like 2 or 3 services. We have touched most of the services, build solution on top of that. So now let's go through the electronic health records. This is just to provide you an overview, right? What is electronic health records? This is based on the healthit.gov. So if you go there, that's how it's defined as contain a patient's medical history, diagnosis, medications, treatment plans, immunization plans, allergies, radiology images, and laboratory test results. Everything is considered as EHR. Allow access to evidence-based tools that providers can use to make decisions about a patient care. Automate and streamline provider workflow. That's EHR, right? So you can imagine if you need to achieve all these things, what kind of software we need to have to do that. And EHR is interacted by multiple people and system. So if you look at that here, physician, providers, payers, medical devices. EHR system sends information to medical devices send information back to EHR, and then lab results, lab orders, everything is interacted through EHR. And then pharmacy integration, you might have seen this when you go to hospital, when you come out, you don't take a paper anymore, right? Everything is electronically done now. Interoperability, even though when the patient goes to a hospital, the patient goes to one hospital, after a certain date, they may travel to another place. And then at that time, if the patient goes to another hospital, they need access to that data from that previous hospital, right? How does that data get transmitted from that place to another place? That's interoperability. Within the hospital setup, they buy our software like EHR software, but they also buy other services, which is around that EHR software. That needs to interact with this EHR system. So that's interoperability. And then clinic, in rural hospitals, rural areas, like 40 miles from a city, these hospitals just do not operate independently. They would have their own clinic or they would partner with the clinic. So there is always a patient going from one place to another place, hospital to clinic, clinic to hospital. That always happens. The data needs to be transferred between that system. That happens here. And then digital patient engagement. So you have seen that with the COVID touchless care, that became a more prominent in healthcare industry. You see that every hospital is coming up with some kind of a system. You go online check-in, do online check-in through your text messages, or there is a website provided. You go put your data, and then when you go in, you don't need to touch anything, right? You sign up front. When you go to the hospital, you just go to the emergency room or the care, wherever it's given, you go there and then come out from that. So hospital is trying to reduce that friction, and that happens with the digital patient engagement. That data also needs to go from EHR, or EHR needs to talk to that system to make that happen. So to visually represent that, you can see that at the center there is a hospital, and then you start from the top, registration. I don't know whether this has registration, and then patient portal, emergency department, clinic, billing, all we discussed. Now you see that the analytics has become part of this EHR system. The hospital needs analytics. That has become a main part of their solution. This transition into that why analytics needed for the hospital. So when we talk about hospital need clinical decision support, one of the major infection happens at hospital, or problem happens at hospital, is sepsis. That's one of the major cause of death within the hospital. How do you avoid that? If you can predict that within the hospital, that can be avoided. And then cardiac risk prediction. Some of these predictions you can see that readmission prediction. When the patient comes to the hospital, if a EHR can determine that this patient might come back because of these reasons, and then the hospital system or healthcare providers can take one step further and solve that problem upfront, that would reduce the readmission. If you can provide that kind of a prediction, that would definitely help hospital. Opioid, you have been hearing from the news, say that that's a major problem in US. If we can predict that and avoid that, that would be great. And then hospital acquired infection prediction, treatment effectiveness, and medication adherence prediction. Each one we can go further, but this is just to provide an overview of why we need this solution, right? And then simplify workflow. We always hear about physician burnout, right? It's industry, it's keep happening. How do you reduce provider burnout? With this solutions like analytics solution, if you can provide a smart searches, provider interact with the EHR system to get some particular information all the time. If we can predict that and provide that information upfront to the provider, that would reduce their burnout. And then intelligent alerting. Intelligent alerting is, there are a lot of systems built around EHR in the hospital. The providers are bombarded with lot of alerts, right? So if we can provide right message at the right time with the right device, that can help reduce the provider burnout. So that's about workflow side. There also we can improve using analytics. And then operational optimization, length of stay prediction. We talked about the readmission prediction in the previous one. Length of prediction mostly helps to determine forecasting and staffing and how best utilize the resources within the hospital, right? And then optimize revenue cycle management. All the hospitals are operating with very thin margin. If we can help them with the revenue, optimize the revenue cycle when they submit for if we can improve the denial management, that's where in the revenue cycle, if we can improve that, that's going to help the hospital a lot. So this is just to provide why analytics is needed, right? Why that one box became important for entire EHR solution. Now we'll go through the solution overview. So like I talked about how we built. So when we started this project, the important part is identifying a SME, right? You will be putting together a team, which is like totally new team. They understand cloud really well. They understand analytics really well. But you certainly need someone understand the existing system. In our case, this system was developed 35 years ago. And with the 35 years ago, whatever the table was created, that table is still in place, right? So someone has to explain that why that was created, how that is operating. And then profile data source tables. The second step is you got to look at all the tables to determine what is really needed. Because if the system is like legacy system, I wouldn't say legacy system, still working system, right? If the system is very old and it has got so much of changes it went through years and years, you would see a lot of tables included, but some of the tables may not be critical. That is included because of some workaround at that time. So you need to understand each table. That's the profiling the data tables, source tables, and then partner with the client. In our case, the client asked for a particular solution, right? So we had a great opportunity to work with customer directly, and based on that, we came up with the MVP. Because we had that opportunity, we were able to go back to the customer, provide the solution, and then get the feedback immediately. Other major problem we had with the production quality data. So what was happening in the organization, we had this test data which was created 20 years back. Whenever new release comes, take that data and then create new environment, start testing it. So whatever the problem we had 20 years back, someone put some junk data, I don't know, junk data or wrong data, that just kept coming. So the data what we had when we started working on it, that's not real representation of what is happening in the hospital. So we had to work with hospital, get the data, de-identify, and then use that to build our solution. This is very critical step. So if anyone is building analytics solution, they have to account this upfront and having that data available. And then cadence call with the AWS. We had wonderful solution architect working with us in every step of the way, and they provided whenever we had a roadblock, they were able to unblock us. And whenever we needed to have like a best practices, identify best practices, they were able to provide that. So if you want to build some solution, have that cadence call, that definitely helps. Explain what you are doing and then get the feedback from the solution architects. Now we will go through this data pipeline. We will start from the beginning. Because our hospital, our software is very legacy software or very old software and still used. At that time, this software used to run in everyone's hospital, right? 30 years back, every hospital had their own IT team, their own data center. That's how they have been operating. So this representation at the bottom, corporate data center, think of that this is running in customer side, running from customer side. And 10, 15 years back, we have come up with the managed services for our customers. So we manage, MEDHOST manages a data center. So we have multiple customer data available there. And so that is also represented here. And in that, we have different applications. You don't need to really look at the application, but look at the data source here at the bottom. One is DB2, another also DB2, and then SQL Server. Because we have multiple technology and we need to provide solution for multiple areas, we have different type of data source. So that's at the bottom. On the right side, if you look at the transactional account, when we started working with the AWS team, one of the questions we asked, okay, So we have this transactional account where we are running all our production workload and providing a solutions to our customer through that workload. That's where we have this RDS and DynamoDB, which has got the transactional data. What should be the best practices for analytics account? At that time, based on the discussion we had, we said that, hey, in our transactional account, we have some of the S3 bucket, which is used for the static website. So we need to make that as a public bucket, right? Based on the security concern, how you are going to have your data governance, it's better to have a separate account. So we decided to have a separate account as analytics account and made sure that none of the bucket can be public, right? That's one of the things, because we are going to put all the raw data into a S3 bucket. We want to make sure that that happens. And then we tightened all the security policy. The data reside, whatever the data, we are going to take it from this data center and going to place there. That's going to be not as it is, right? It's original data. We are not going to do a de-identification, anything. It's going to be original data. So we had to come up with the policy. I oversimplified this diagram on the left side, but next page, when I go to the next slide, I'll expand that part. So you see that AWS Glue, that's our compute. That's what that one connects to. That compute connects to data center and pulls the data. You can see that AWS Direct Connect. That's how we connected between our cloud account to individual data centers or to our managed data centers. That's a MPLS connection between cloud and that. That is single pipe, that is encrypted pipe. So it's a very secure way of getting the data from the facility to our AWS cloud account. Once we get that, we put that in S3 bucket. I'll go through the next step. And also you can see another diagram. AWS Glue connects back to the transactional account to get the data from Amazon RDS and Amazon DynamoDB. That part is easier because it's cloud to cloud. Next one is a data pipeline. This is the expanded version of that small box, that analytics account. You can see that on the left side, we have this Amazon Event Bridge. There is one more box here. I left that out purposefully. But that box basically establishes this event bridge, sets up this event bridge. Because we have thousands of hospitals, and each hospital operates in a different time zone. Each hospital has a different type of data set. So we need to determine what is the best time to connect to that server and pull the data. And the purpose, like how much data we are going to pull, what is the operating time of that hospital, and what kind of data set we need to pull. Based on that, this event bridge gets set up. So this triggers every day based on the facility and based on the product. You can see that at the top, facility 1 revenue cycle, facility 1 peri-ops, facility 2 revenue cycle. Basically, this connects back to that service, pulls that data. Once it triggers this Glue job, then Glue job connects back to the facility, pulls the data, and then places that into raw bucket. Once it places that into raw bucket, that gets normalized. Once the normalized data happens, and then reconciliation and measure happens. You can see that at the top, there is some metadata, get metadata from a Postgres database, right? What we have done, because we are going to collect this data from a different data source, and also different versions of servers, software running, right? One hospital might be running a version 1, another hospital might be running a version 2. So there could be a change in DDL. So we need to account for that. How do you account for that? That information gets stored into the metadata store. So based on the information saying that, hey, this hospital is running with this version, based on the metadata, it goes, collects that information, places that into raw bucket, and then process from there. Once this data gets processed, our data mart is Amazon Redshift. So it pushes that data, upsert the data into the Amazon Redshift. So now the collection of the data is completed, and we normalized, and we have the data available in the Redshift. This has to be available, we need to make this available to the end user. That's where Amazon Quicksite comes into. So here is the Amazon Quicksite. This is also a little busy diagram, but you can see that Amazon Quicksite is the tool we use for visualizing the data to the end user. When we provide that visualization to the end user, we don't want to provide Amazon Quicksite as a separate login and the user needs to log in and get that information. We want to make it look native to our application. So to make it look native to our application, if that needs to happen, we need to integrate with our identity management, IAM, right? So we have our own identity provider. You can see at the left side there is an identity provider, and then we use Amazon Cognito to integrate that. Our identity provider is a OAuth OIDC provider. So Cognito has a configuration to connect to that external identity provider and generate a jar token. Once that jar token is provided, you send that to Amazon Quicksite, and then from that point onwards, it will look like a native to the native application to the end user. But essentially, it's bringing another page where it gets displayed. So here is the sample dashboard. I'm not going to go through that dashboard. This might not be interesting to you. You really want to know how this is built and how to use this system, right? And then I'll go to this one. This is another sample data we built based on that Quicksite. So now moving on to the lessons learned. So that's the architecture, what we learned. So some of this detail might look very basic or normal thing, but these are all the things, critical things we learned, right? We need to have a dedicated SME. If you are going to start this project, make sure that you get buy-in from your management or team saying that I want this person available for this many days, right? That's very, very important. And then build a metadata-driven ETL engine. That's the one we discussed in the previous one. We maintain that in the Postgres, saying that what is the DDL difference, what is the data source difference, that gets maintained. So you don't need to make code change. You don't want to build every time when you release a code, oh, I need to go make a change to our glue job. It's driven by that metadata. Build your data model to adopt multiple EHR vendors. Even though we built this solution for our MEDHOST EHR, when it goes to the corporate customer might have other EHRs. So we cannot say that, oh, our software works only with our EHR system. We need to really make sure that it works with the other EHR system. So the model is built based on that. When they come back and say that we need this data, we can put that metadata and connect to the source and then get that information, make it available. Account full multiple versions of DDL. I think we discussed about that. Have constant customer feedback. We were very lucky that we were able to come up with the MVP based on the customer need. So we were able to go back to the customer and show the tool and then get the feedback immediately and incorporate that in our tool. Utilize technical architects. That's the one we discussed in the previous one. Work with the AWS team. Work with the AWS team. They are great resources and they provide you all the best practices and how to do things, right? Never underestimate ETL speeds. So when we started working on this project, we started looking at it, okay, let's create this glue job, right? We created the glue job. We wanted things to work first. So that took like 2 hours to pull this data. 10 million records, it took 2 hours to bring that to the cloud. We started working on that and then we worked with the AWS team and said that, oh, okay, you can optimize this way. Then team went back and optimized. When they optimized, they brought that 2 hours to 15 minutes, right? Once we brought that to 15 minutes, still it's 15 minutes long time. What we did data compression at the source. That increased our speed dramatically. So from 15 minutes, it came down to 2 minutes to get the data. So you can see that. So I would suggest that do not concentrate on optimization upfront. Concentrate on having a solution in place, but you can go back, rework on that and make the optimized process and make it faster. Because this is not a transactional data, you can work on that later stage, right? And then we'll go through the business benefits. Now, because of this solution, we have a financial dashboard for our hospitals. CFO can have a single view and they get multiple data sets in a single page. And prior to this, they didn't have options to look at one facility, how this facility is performing against another facility. That option was not available. This provided that option. You can go to the dashboard and say that, hey, I'm looking at this facility, and then switch another facility and look at that, right? And then for the billing analyst, they didn't have a clear view of, okay, I have been doing this coding, which payer is paying on time, which payer is getting delayed, what is getting denied. That view was not available prior to this. Now they have a clear view. With that view, they can improve their billing efficiency. And then prediction of denials, that's the one I talked about it. So for the customer, it's a low-cost solution. They don't need to have any infrastructure, right? You can see that in the diagram, except that connectivity, nothing is running in their data center, everything running in our cloud. And you saw that I talked about the serverless. You can see that everything is serverless now. So from MEDHOST perspective, until the customer starts using the service, we are not paying much to AWS. Based on the usage, it's going to go up, right? And it's a secured solution. Every piece we selected here, it's a HIPAA compliant solution. So we were able to build without any issues there. Now we have a platform for additional analytics going forward. So what's next? The title is wrong. It's not key lessons learned. It's what's next. We are going to bring in other data sources from the emergency department, operations room. Your Care Continuum is the product which we use to connect for clinic to the hospital, and patient engage platform. This one we discussed about that touchless care. Interoperability platform. We have built a FHIR data source. We are going to bring that data in, and also that's going to be used. Build AI and ML solution on top of it. Now we have a raw data in data lake. It's easier for us to get that and utilize that data to build a solution. And then enable data scientists access. Complete data governance policy. We have started working on the data governance policy. We have not completed it, but we will spend time to complete that as well. I think that concludes my session. I'm in LinkedIn. Connect with me.